So I am aware this is a last stop before lunch, so I'll try to be entertaining and exciting and also finish on time, if not a little bit earlier, so we can all go eat. I'm hungry, too. So a little bit about me. I'm a software engineer currently working at Capital One. Throughout my career, I was specializing in front-end, but for the past kind of year or so, I've been delving more into designing data architecture and data modeling, more or less working between the front-end and back-end. That's just really why I got excited about this pattern and why I'm talking about it today. So today, we'll just cover a definition of what is backend for frontend, why is it useful, and also how GraphQL makes into all this. And also a little bit more context, like why am I talking about data design and APIs here? I mean, what does frontend do? Frontend essentially just takes data and render it. That's basically its job. And it's becoming really, really like a thick UI client these days because it needs to handle so many things regarding data logic and such. So since I've been exploring this, I thought, well, if we can offload a lot of the logic to another layer that's not specific to front end, it could help reduce like the thickness of the UI and the complexity of it. So let's go into it. So what is the BFF? I mean, this is just an excuse to get cute animal pictures in here. And also the acronym BFF, just can't help myself. So the definition of it is actually quite simple. It's just three things. It's a data layer, keyword being data layer, with application logic in it. It should only really concern about application logic, not business logic. It is pretty easy to sort of move that into this layer because it seems easier. You have control of it. But business logic is something that's unchanging no matter what your front end is. So it should really still reside in your back end and services. A BFF should be coupled and really tightly coupled to a user experience. That's not exactly the same as a user interface. And user experience can have multiple interfaces. And most importantly, it should be developed and maintained by your front-end team or the same team that's in charge of delivering the user experience. And we'll go through some scenarios and we'll see why that is important. So this is really just a mental model, like simple visualization of what back-end front-end really is. It's really simple to visualize. You have a front-end, you have the middle layer, that's the BFF, which talks to the data services. Now, if you're familiar with sort of using general APIs or orchestrator, this may not seem that different. So we'll go through like why this is different than that. So maybe we start with our front end just directly talking to database or data services. And then at some point realize probably best to orchestrate it because it's just the UI can be a little less heavy. But again, this is a general purpose API or an orchestrator. The difference between the two is really just the kind of responsibility that we assign to what we need to do in this layer. The BFF is, what is it good for? So let's just go over scenarios really quickly. So let's say you have a product that's doing really, really well on web. Now you need a mobile experience. So what would happen is you add something else, yet another front end, and now you need to modify the general API, most likely, to give the data that mobile needs. So now your original UI has not changed, but yet you probably need to accommodate the change as well and test and release. There's a lot of logistics now that needs to happen between all the teams working on this. And it could be very fragile because there's too many touch points. And also you could really overload the general API. Now they're serving multiple mobile clients. And what happens if your mobile now needs like 3 different clients? So if we had a BFF, then the new BFF would just be started for the particular new experience that you're building, the mobile. You don't need to affect anything to your existing application. It could exist as it is. And also I sort of drew up here, like maybe your new experience only needs 2 data sources. So it doesn't need to concern itself with the third one. It could just be lighter and simpler. And also now the teams working on this can just really work on their own cadence and release schedule. This matters quite a bit if you're in a larger organization and there's just a lot of coordination going on. Another scenario is you just have one UI. I mean, the previous example, if you do any research into BFF, you probably will see that as a classic example people give as to why you want to use it. But it's not like every day or every product will come up with a new client or a new experience you need to serve. So you may be likely to come up with something like this where your UI is doing well, but then according to user research or just new features, now you need to really upgrade it or redesign it. So what then happens is maybe you need to really like change all these different touch points, the UI, the general API, maybe the data service, and maybe you're retiring one data service. So the complexity can really grow if you have another consumer of the API, for example. Or then what happens now if it needs this one that has been retired from the general API. So with the BFF, it's visually it still looks a lot the same, but as you can tell, like it's now contained and isolated changes to just that particular middle layer. And it's avoiding all the side effects that we're talking about affecting other consumers or other UIs. And also we're offloading the application logic in here, so it means that probably the UI, the web UI changes would be much less than before. And I think I should know like what I mean by application logic. So for example, if you have like a rewards program, like hotels.com, you say 10 nights, get 1 night free. That's business logic. That should not be here. But there can be a lot of things that happen in application logic. So like how you present promotions to your client, when you present promotion to a client, that could be sitting here in the BFF instead of the web UI now. And you know, like this shows also like it's like how does this really help the UI in the end? You're still making a lot of changes everywhere. So this is really where GraphQL comes in, I think, because it could help really reduce a lot of the overfetching and underfetching that could still happen with the BFF, especially if that is designed still with the traditional kind of REST API architecture. So if they get quick definition, I don't know if everyone here has like that much knowledge of or have usage of GraphQL already. So it's a data query and communication protocol. You can obviously read and write data. You can also implement or subscribe changes to such data. You can compare it to REST. Of course, it does a lot more than just HTTP requests. You can communicate with WebSockets. You can directly connect to database as well. It does require both sides, client and server-side implementation, which actually is a very good thing. And we will look at it. So in the demo that I'll show later, it would probably make this kind of high levels a lot more clear. But essentially, the main benefit of GraphQL is that the UI is in charge of its destiny. So it only gets what it requests. And as front-end developers, you have a lot of tooling and a lot of ways to just clearly understand what the data model is available to you. I often run into the problem where I get documentation of a REST API endpoints that I need to hit. Great documentation, but then I find the data is not what I need, and I'm not sure why. Am I not passing the right query parameter, or is it just not available? And I go through like a whole day finding out what I can do about it. Maybe there's nothing I can do about it, and then it's just more and more work on top of my original idea of just updating a UI. And depending on how you may want to implement both layers, the front end and the back, for example, if you have a front end as TypeScript, BFF GraphQL that's also TypeScript, you can essentially share the same data interfaces between the two. So even during development time, you can avoid a whole lot of problems of passing the wrong key or not understanding what you can render or what the type is. And the GraphQL resolvers is really powerful. You can combine multiple resolvers together. You can combine multiple different kinds of requests. So as far as the front end goes, for example, if you need to log in, well, that may not be a great example, but you need to do some certain action. The front end can just fire one request. The BFF will still fire 3 different requests to the back end or some other network services, but as far as the front end is concerned, there's only one loading state it needs to be concerned about. It doesn't need to know 3 different data sources loading state to try to determine what it needs now to render. Let's do live-ish demo. Hopefully this goes well. Let's embrace the challenge. Okay. So these are all very sort of high-level talks. So I do want to show like how simple it is really to implement GraphQL in a server side as well as the front end side. I don't know if it's really visible. Hopefully it is. So this is just an example of a simple implementation of the server using Apollo, which is one of the most popular open source framework out there to implement GraphQL server. You have the server, it takes that type definition, takes resolvers, that's it. Then the type definition is literally you're just describing what data is available in the server. and then what the query shapes are for these 3 queries. And then the resolver is just matching to the query shapes, and then it's just pure functions, basically. You can return strings, you can return groups of data, or a single data point. It's a little hard to see, but we'll try this. And this tool, this code sandbox, is a great way to really just test out GraphQL without setting up a backend server or anything. This right now is just reading from a data JSON, so it's just easier to do. So remember how I said was it doesn't subfields. Yeah. So yeah, this is great. It tells you why it's failed. It's because I need subfields, and it knows that because it's directly getting the schema from the server, so it knows what is missing and what is requiring. So all of these are live at the time that you're doing it. You don't need to go look for additional documentation on how to do certain things. And if you look at the resolvers, it's really simple. Like this does nothing. It says nothing about what data I'm returning. So if the front end today says I want more than just title, all it needs to do is just ask for it. There's nothing to change in the data layer inherently. So that's a major difference than like the typical REST API. And I'm not going to go through really the whole example, but as you can see, you can also return strings, which is sometimes very useful, especially if you want to offload some particular messaging logic to this layer instead of putting in the UI. You can create resolvers that just returns messaging upon certain conditions, maybe. So that's the server side. And just also to show, resolvers can be more complicated than that. Like this is a local example is resolvers talking directly to a local DynamoDB database I have. So it's just literally inserting, doing all the CRUD operations against it. Let's see. And another thing about the schema, as I was saying before, if you have the need of tying both front and back end together for the data interfaces, it's also very simple. There is a GraphQL CLI, which you can just execute command to get schema. You have your server running. You get the schema. It would generate something similar to this, which is just a schema JSON. This is auto-generated. And then from here, you can see around JSON file, you can do a lot with it. One of the things that a lot of people have done is just to use another open source library where you can write your own to generate a TypeScript schema. And then your front end, of course, can import it. Your back end will use it. You'll have no problem of knowing what's required. And it also gives you kind of sort of generic GraphQL responses and this sort of generic server responses. So that's that. And then we can look at the front end. So this is probably the exciting part, maybe, because it has to do with React. And of course, GraphQL works with all different kinds of framework. Angular, Vue, you can use that too. But it is inherently working better with React. This example that I have is also from the Apollo. The other popular library is Relay. They are similar in the thing that you want to achieve, which is help you reduce fetching, loading, and also helps you caching. So to actually wrap it in React is also very simple. You essentially just wrap a provider. If it's Relay, it would be like Relay provider. The client is just where the server is located. This is just my local GraphQL server running. And then we can look at, and then you will compose your actual view. So React Apollo 2.0, I think, came out with the component GraphQL that you can essentially use it to compose stateless components from it. You have a default component, this is the GraphQL one. It takes in the query, the actual query you want to send to the server. You can define some options of how you want to fetch. This is really great at just helping you reduce your network request. And then it always comes back with a loading error and then the data that I'm requesting. So you could use basically loading error here to already manage your component state. You don't really need to use Redux or other means. So as you see, compose here, if it's loading, return some loading. If it's error, return some error. And otherwise, it's just very typical React component rendering here. And then another thing is, the data elements here are exactly what I pass in for the query. So there is no, like, I absolutely will know what this name and the key will be. There's never be no mistake. I'm keeping this here as an example. If I'm not using it, I usually wouldn't keep it here. So this is another GraphQL kind of advantage, is that you can create fragments. Because it's very likely that you have nested data anyway, although it is recommended by GraphQL to have your data structure be more flat, and then you don't need to fetch like layers and layers of data. But if you do, if you want to reuse it, you can create these kind of so-called fragments. And then it will render some kingdoms in the 7 kingdoms. And there's a lot of other tooling. This one that I typically use. Why is this like this? Weird. It's almost like a Postman. I see. It's almost like a Postman tool, but it can handle HTTP requests and as well as GraphQL requests. So this is something you can just use to sort of mimic your front end a lot better, because you can pass in headers and out queries. Another thing about, I'm not going to use this because it's not easy, is if you have, let's say you're new to the team, you have no idea what you can request, it's very simple. This is a generic type of query you can just fire. This is another tool that comes with every GraphQL server, basically. It's a graphical interface for you to interact with it. And this generic query here would just give you whatever is on the server that I can interact with. And it will give you all the data shapes. The stock is auto-generated as well, so you can see the data types, etc. All of this already helps cut down probably your development time by half, just at least not having to go through which data points I need, etc. So that's one other tool. And this one is if you're hosting your own, when you're hosting your own, it's also very hard to see. If you have multiple GraphQL server, you can generate a schema that gives you kind of relational view of what is happening between all the data points that you have in your server. And all of these are sort of just open source and free and out there. And it's directly querying the database. There's nothing querying the server. There's nothing special you need to sign up for it. And another thing that I do get asked quite a lot is what does a update type of query looks like? Because I think a lot of the examples really typically only follow queries. To update or insert or doing anything manipulation to a data is called a mutation. This is sort of a typical mutation query. And you will pass in your query variables down here. I'm sorry, I don't know why this looks like this. But anyway, you can pass in your query parameters. And again, this is getting the schema from the server. So if I did something wrong here, let's say, I really need to just do this. There we go. Let's say I pass in something wrong, it would just highlight me and tell me you cannot pass in this as an input because it's missing something. And if I have marked anything to be required as a input, I take it out here, it will also mark as why it's wrong. And you can literally copy this exact thing into your React front-end code and have it run. It will guarantee to work. And let's see. Yeah. So it's a live-ish demo. I'm not really live coding because I don't want to fail. And but I think hopefully from these really quick demos you see it's really easy to set up the server. It's very easy to use in React. It already comes with a lot of component, modular, and composable based features that you can use with Apollo and with Relay. They are really very similar. And let's go back. So it's really just to summarize why, how you can really enhance the UI and the backend front end with GraphQL is that the whole point of having a backend or front end is so that you are lessening the load of your front end. You're moving data logic, application logic out of it so that your front end can just focus on what it does best, which is just this design consideration. There's a lot of user experience consideration there already that you need to handle. And the things like overfetching, underfetching, as well as managing states, you could essentially just use GraphQL. You don't need to use Redux or anything else with it if you so choose to do so. Apollo and both Relay underlying it, their state management is based on Redux actually. So you could combine your local application store with that store together, and it would be in sync. It would just be in one store essentially that you can interact with. So you could try both ways, but essentially it's just you have a much easier way of managing the state that comes like a side effects through data fetching. And yeah, so it also reduces the burden of data logic in backend or frontend, because as you see, like even to the point of what kind of data they need to reply with, how much I should reply with is really already taken care of for you by GraphQL Server. You don't need to write anything additional. And of course, ease of development is a big thing because we're developers and we want easy day in a job. Another cute animal picture. So GraphQL really is best for forever with BFF and UI. I think to really leverage the BFF architecture, having something like GraphQL would just really propel you forward. Otherwise, you will still kind of get stuck with the same problem that you may have with general purpose API. So there are some resources. I will share out the deck after the talk is over. And thank you for listening.